We've really come full circle in this module. We started by learning how to develop automated tests using unit tests. We then learned how to debug our code with PDB, followed by sections on packaging and distributing our code with distutils, and we finished off by learning how to install third-party code into our Python installations. One of the programs we were able to install in the end was a tool to help us run the tests we developed earlier. That's quite a trip. Here's a more detailed list of the topics we covered. The unit test module is a framework for developing reliable automated tests. You define test cases by subclassing from unittest.testCase. The unittest.main function is useful for running all of the tests in a module. The setup and teardown fixtures are used to run code before and after each test method. Test methods are defined by creating method names that start with test underscore on test case objects. The various testCase.assert methods can be used to make a test method fail when the right conditions aren't met. Use testCase.assert raises in a with statement to check that the right exceptions are thrown in a test. Python's standard debugger is called PDB. PDB is a command line debugger. The pdb.setTrace method can be used to stop program execution and enter the debugger. Your REPL's prompt will change to PDB in parentheses when you're in the debugger. You can access PDB's built-in help system by typing help. You can use python-m pdb followed by a script name to run a program under PDB from the start. PDB's where command shows the current call stack. PDB's next command lets execution continue to the next line of code. PDB's continue command lets program execution continue indefinitely or until you stop it with Ctrl-C. PDB's list command shows you the source code at your current location. PDB's return command resumes execution until the end of the current function. PDB's print command lets you see the value of objects in the debugger. Use quit to exit PDB. Virtual environments are lightweight, self-contained Python installations that any user can create. PyVenv is the standard tool for creating virtual environments. PyVenv accepts both a source installation argument as well as a directory name into which it creates the new environment. To use a virtual environment, you need to run its activate script. When you activate a virtual environment, your prompt is modified to remind you. The distutils package is used to help you distribute your Python code. Distutils is generally used inside a setup.py script which users run to install your software. The main function in distutils is setup. Setup takes a number of arguments describing both the source files as well as metadata for the code. The most common way to use setup.py is to install code using python setup.py install. Setup.py can also be used to generate distributions of your code. Distributions can be zip files, tarballs, or several other formats. Pass --help to setup.py to see all of its options. Three common tools for installing third-party software are distutils, easy install, and pip. The central repository for Python packages is the Python Package Index, also called PyPI or Cheese Shop. You can install easy install by downloading and running distribute_setup.py. You use easy install to install modules by running easy install package name from the command line. You can install pip via easy install. To install modules with pip, use the subcommand notation pip install package name. Along the way, we found that divmod calculates the quotient and remainder for division operation at one time. The reversed function can reverse a sequence. You can pass -m to your Python command to have it run a module as a script. Debugging makes it clear that Python is evaluating everything at runtime. You can use the _file attribute on a module to find out where its source file is located. Third-party Python packages are generally installed into your installation's site packages directory. Nose is a useful tool for working with unit test-based tests. Thanks for watching, and we hope you enjoyed Python Fundamentals.